that can come back to you as well in terms of, so accountability is something which is very, very serious about, and everybody is trying to understand how that can be built upon. So these are the problems that you typically look at when you are looking at deploying AI for not just, I would say simplistic use cases are fine, but as the problem statement becomes more complex and as the use case becomes more important, you are answerable to many, many, many people. So that's where ML Observability as a framework comes into picture. Now the myth is, I mean, if you are a data scientist, you would know, but most of the business guys' assumption is once I put the model in production, the model will continue to work with the same accuracies, or the model will continue to work in a similar nature. But the problem is your reality is probably would be this, where in a micro time frame, you may be violating certain smaller bandwidths of accuracy. But if you do a macro analysis, your model is drifting from the day it went in production. So this is not so sexy problem to think about, but it's actually the critical ones to do. Now, quickly about ourselves, I think I have already introduced what Arya does. So we started in 2013. So we are one of the first deep learning startups out of India. So we had an enormous amount of experience in building models and pushing them in production. So our experience of building this platform is our realistic work that we have done with our customers and our efforts in productionizing that. So what we offer, as I said, is an AI PaaS that has 3 components. One is the APIs, which is plug-and-play APIs. Any business, if they want to use pre-trained models, there is a specific use cases where you can pick and then use them as APIs. Next is the solutions. So solutions is underwriting solution, claims automation solution, fraud monitoring, where you can customize by providing training data, and then frameworks. So let me talk about one case study here. And we have been deploying this for quite some time. We have scaled this quite well. Now, why do we think the model fails in production, right? So there are various reasons. So one is maybe the model is started seeing new data, which it hadn't seen in training data. That could be one issue. The other issue is data drift, meaning the data itself that you have been training the model on started drifting from time to time. So you started receiving new data points, new data sets, which was not again trained in the model. There could be a concept drift, meaning the target definition itself might start changing. For example, an ideal customer, right, before COVID, after COVID, changed a lot. Then there could be a concept drift there, and there will be adversarial attacks or undefined operating space. So what we call undefined operating space is, some bot, algorithmic trading bot went haywire in let's say 2010, I think, created a huge market chaos at that point of time. So your AI need to be controlled. Whenever you are productionizing AI, you are adding a risk to the business. That's the fact. You are adding the value, but along with the value, there is an associated risk. So how are you managing this associated risk? So these are the few things that comes up into play. So let me take a case study. So one of the case studies which has a huge amount of regulations, heavy amount of diligence was in life insurance. So in life insurance, insurers underwrite the customer, right? Saying that whether I can issue a policy, can't issue a policy. They do multiple things before they can issue a policy. So given this as a case study, so currently they use rules engines because rules engines are quite simple to understand. So they say that, okay, your age is less than 30, your sum assured to income is 1:10, then they can approve that immediately. So you may see a message down in the application form, right? Yours is an STP kind of case kind of thing. So those are simple rules. Now the problem that we are trying to solve is, can we use AI to automate the underwriting decisioning, which is more complex. It has health issue. It needs to analyze the health risk and financial risk as well. So the stakeholders are multiple. As in for this problem statement from the customer, they were data scientists, data managers, like the guys who own the systems. There is business users, there is risk teams and regulators, because when we productionize this model, then the Arya.ai has the controls on what we do in production. Now, for us to push the AI solution in production, they have given us the specifications. One is transparency. So it has to explain why the model has made the prediction. So these are the requirements that we have gathered / understood while productionizing the system for this critical use case. So this was not given to us from day 0. This was kind of evolution has happened over time to figure out what is required to push this in production. One is transparency, meaning whatever the prediction that you are giving to me, I need to know how the prediction has been made. That's one. Second, I also want to know what could be the source of this prediction. Meaning, let's say the system is recommending issue a policy, but on what basis? Meaning, can I understand what is the source? Then what happens is, if the model has made an error, then I know that in my training data there is itself is a labeling sampling error, and so on. And then they have asked us for promised SLAs, meaning, okay, when we are going in production, the accuracy is 99%. You have to promise that 99% can be maintained for all the automated cases. This is when it becomes more or less a business problem now. So they wanted a promise SLAs. They wanted a consistent system, because very arrogant or a confused system cannot be trustable in production anyways. Third is the bounded risk. While AI is making a prediction, the error in terms of how much it can make or how much it cannot make versus the guidelines that I follow, AI should also follow, because my business has to follow the guidelines of the business given by Arya.ai or RBI or data privacy laws and all of those things, right? So my risk should be bounded. And fourth is the auditability. So whenever Arya.ai audits my decisions, you should be able to give me an audit report on that case or on that model or the entirety of the case. And then compliance. So I will go to multiple markets. So I want to have this system to be scalable across multiple markets. Each market has its own AI governance regulations and all. But the problem in financial services is one is coerced feedback, meaning taking this insurance as an example, life insurance, whether you are right or wrong, you will know only when a person dies in life insurance. So that may be 1 year, 3 years, 10 years, 50 years as well. So the feedback is very much delayed and very much distributed, right? That's the problem that we have in insurance. Second is strict regulations. I think at least in India, it's not strict enough, but at least in certain areas, it's very much clear that you cannot use black box models. It has to be unexplainable models. Fourth is inference. The interface matters a lot, meaning whatever they have requested, right? If you do it on ad hoc basis, for each and every request, that's an exercise of 3 months. Meaning, let's say you want to send an audit report. Then there have to be the entire team sitting in a room talking about how the model has made the prediction for next 3 weeks before they can understand how the model has made the prediction. So the interface of this ML Observability framework matters, because you need to allow participation from all stakeholders in one place. And fourth is the promise SLAs, as I said. Now, one option is you can do this as a service delivery. So you build a model, you say that, okay, I have my underwriting solution. Whatever is required on the other end, I'll provide services on top of it. So I'll have data scientists to work on create dashboards, maintain dashboards, send emails, engineering team to look at these, or for bounded risk, I'll continuously work with you to understand what is the risk guidelines required. I'll implement those guidelines, I'll maintain the guidelines, and so on. The conclusion is, if you do this, you would become a massively large services company who are charging 3 times more than the product cost itself, because you need a lot of people to do this and to deliver this. Now, what else is available? So there are certain tools and platforms that are solving this problem today. There are horizontal ML ops platforms. They also do multiple things serving to these problem statements. So for example, if you take horizontal ML ops kind of platforms like GCP or AWS or Azure, they have certain explainability with them. But again, the depth, right? So if you look at these, there is a tick mark, but the depth is where it changes. It matters a lot, the depth of it. So most of the horizontal platforms are pretty much, they do everything, but a very high level, very much in generic explanations, generic alerts, and so on. And then you have ML experimentation tools, which are very, very good for auditing your ML models. So for auditing auditability perspective, ML experimentation tools gives you a very good interfaces as well. And then there are ML observability tools. For example, there is players like Fiddler, Arise, who are commercial applications. Their problem statement is to solve the ML observability. So the experience or deliverables as compared to ML observability platforms versus generic ML ops, it is at least 2x to 3x kind of change. And you also have open source frameworks for each and every problem separately. Then again, as I said, you need to have a team to manage all this implementation and everything. So when we were designing our Arya.ai framework around our products, so these are the components that we believe is required to productionize this: explainability, monitoring, auditing, and policy controls. So this is what we have built in Arya along with our AI/ML models today. Whenever we are productionizing any model as part of our service, so all the XAI framework and XAI implementation goes along with it. So explainability, for example. So for deep learning, we have our own proprietary method called backtrace. So we believe that sharpen line while gives the explanations, but it's not consistent. There was a lot of debate on whether that should be trusted or should not be trusted, because it varies from baseline samples, or it is created from synthetic data sets which may not represent the reality, and so on. So hence we create a probability algorithm called backtrace. So that can help us to understand the neural network, how the neural network has functioned, and the feature importance as well. We are also providing sharpen line. If you still want sharpen line, we can still get that. So deploying XAI is quite simple. You upload the model and you start sending the predictions, and you will get an XAI report for each and every prediction. And we are able to generate two-to-model explanations. These explanations can be local, regional, or global. Next comes similar cases. So for example, let's say the AI engine has denied a policy. Now the underwriter will ask us, right, why did you deny the case? While we give the explainability, then we also need to give additional evidences. Additional evidences is similar cases. So we try to map the similarity between the current case and the cases in the historical training data. Let's say there are 1 million cases in the history. We map the similarity between this and that and pick up the most similar cases from the past. The intention is to give them a directional input saying that this 100 cases could be the source for the model to give me this prediction, to reject, to accept, or to load, or whatever the prediction could be. And to do that, we use multiple methods. One is feature importance similarity, meaning as I have feature importance for each and every case, I can just map the feature importance similarity and find the most similar cases. I think I would trust this as compared to data similarity or prediction probability similarity, because in data similarity, data may be the same to some extent for certain number of parameters, but one parameter could change the decisioning path. So that could be. So now, as part of the explainability report, what we give them is for each and every prediction, we give them a list of past policies, and we map the feature importance for all those past similar policies. Now, when an underwriter gets the prediction, he'll get this as the explainability report itself. Now, monitoring. So we monitor our models in production, both model monitoring and data drift monitoring. So we use PSI and KL at the moment, KL divergence. So you can define the default threshold, or you can customize the threshold. So you can say that above 0.2, I want to get an alert, or above 0.4, you want to get an alert, for example. So you can do the same thing for all features actually. In fact, let's say you have 100 features in your model. We monitor all 100 features. You can define the baseline as well, but necessarily we monitor everything to figure out when data drift is happening, when model drift is happening. So this helps us whether the insurer is using it rightly or not. Meaning, we are the guys who's doing the underwriting. Let's say the insurance systems are sending some wrong data, which was not exposed in the past, or some random samples, then our accuracy will get affected. So we need to define the ownership of the task. So the alerts helps us to tell us that there is something wrong in the data, and there is something wrong going in the model as well. If it is ours, the model problem, we will do an audit on the model and figure out what's the issue, and then inform the user saying that you are sending a different kind of data. Something might have happened in your data pipelines, for example. So this is helping me to figure out a problem, and it's also helping me to figure out the solution as well. Because of this, I can say that, okay, fine, I can maintain my accuracies in a stable manner because I know when my model is going to fail. Then I can meet my SLAs as well. Yeah, and data drift, as I said, so whatever the features that you have, we monitor data quality and data drift as well. Data quality is, we can say that, okay, how many empty percentages was there here versus training data, compare that. Are you seeing more empty in the recent times as compared to training data? Or what is the min and max values? Has that range has changed? All those things from there. And then we do bias estimation. So you can customize what is a sensitive pool, non-sensitive pool, and say that whether there is a bias in the model as well. So this is required as part of the regulations. Yes, in India, but it's not followed very aggressively from that point of view. And then alerts, as I said, you can define a threshold and create an alert on any data or any model performance. So I can say that feature A, if it violates PSI score of more than 0.3, get me an alert. And feature B same, feature X same, feature Y same. So you can pick up any features and create as many alerts as you want. From an auditability standpoint, there is a case-wise audit and there is a model audit, right? Case-wise audit as in, for this prediction, what has happened? What went wrong or what went inside the model? So one of the things that we do is we capture metadata for each and every prediction. Meaning when the model is making the prediction, we capture the snapshot of what is the model status, what is the model accuracy, what is the model open alerts. Meaning the intention is if something went wrong and there was an alert, and data science teams have informed the business that there is something wrong in the data, but that has not been executed. Now we are talking about ownership of the teams, right, where the error has happened. So we take the snapshot for each and every prediction. So when an auditor or a regulator comes in, they know that what was the state of the model at that point of time. This can be viewed by the business teams directly themselves also. On the model level, you can create bunch of cadences like, okay, I'm now upgrading my model. Have I done enough UAT? Have I compared my model? Have I done enough analysis before I productionized it? So you can define what are the specs that you want, and then you can start executing them on the platform. Fourth thing is AI risks, right? Let's say for insurance as an example, so there are product bounded terms and conditions, meaning I cannot issue this product for, let's say, somebody who has salary less than 4 lakhs. Or I cannot issue a product if the model is biased. Or for this product with a sum assured being, let's say, 100,000, I cannot do this in an automated manner, even though the model is confident on top of this. So there are multiple guidelines or policy controls that would be required for a business. So what we have created is a policy orchestrator. So we pick up the features that we have received in production and in real time. We pick up the model output for those, and we also pick up observability monitors. So then you can combine and create a policy out of it. So for example, let's say I want to automatically move a case from STP to NSTP if I find a bias. Then what I'll do is from monitors, I'll pick up bias monitoring. I'll define my threshold, and I'll define my feature value, and say that for this feature value, if the monitor is alert, override the prediction from yes to no, for example. So you can also define the target deviation as well, so that you can control where it can act, where it cannot act. In short, what we are trying to do is something like Asimov principles, right? So a robot cannot harm human. Maybe for that use case, or maybe for that prediction, the prediction is kill human, but you write a policy saying that don't kill human. Then the policy will override the model output. This is kind of very simplified assumption. So this, you can pick up any kind of problem statement, for example, let's say diagnosis, right? In medicine, I may not recommend certain diagnosis if you have some XYZ or something like that. So you can define those kind of policies here. Now, by implementing all of this, we are able to productionize one of the complex AIs that we have built uses deep learning. Even though we use deep learning, we are able to now productionize it. We were able to provide confidence on model transparency, because for each and every prediction, we are giving the explainability report that goes to the underwriter, so they can see what is happening inside the model. Second is we are able to adhere to SLAs. So we are now saying that, okay, we can promise the performance. Given that, we can also tell you if something is going wrong, so who is responsible, what teams needs to work on, how much they have to work on, and all of that. Third is if time needed, so we can provide both global explanations and local explanations as per the need. Now we can accelerate time to production, meaning if I don't do this, the next caveat is I'll run it in parallel run for next 1 year, and I see the consistency of the system, then I start automating. That would be the second option. Whereas in this case, as it's been done properly and a lot of auditing and everything has been happened, so you can actually productionize it very, very quickly. Even it's a mildly working model, you can still productionize the system. Fourth is AI uncertainty can be managed by policies, which means that no matter the model accuracy is, let's say, 65%, for example, but that's all the data that I have. But you understood that for a certain segment, this model is working fine, even though it's let's say 10,000 samples. For segment of people coming from Bangalore, for example, the model is working fine, which means you can start using the model, right? So you can do that by defining the policies. Right? So you can simply say that if the customer is coming from Bangalore, then I'll use the model prediction. If not, then I'll not use the model prediction. So you can identify the segments where it works and then define the policies accordingly. And it provides a common platform for everyone. So underwriter can log into XAI, see what's happening. It's understandable to the business teams, understandable to regulators, understandable to auditors. So that's one of the key nuance USP that we were looking for, one common platform for communication. Now, as we have done all of this in XAI, so we are now launching this for not just for our own use cases, but for everyone. We believe that there is a lot of pressure on model manufacturing, meaning people are manufacturing a lot of models and putting them in production. Now, you need a framework which is easy to use, helps you to do all these things, and helps you to ensure that the data scientists and the business teams are able to deploy with confidence and all. So we are launching Arya.ai for public. So the early access will be launched as early as October mid. So if you are signing up, you will get a big offer in terms of early access and all. So we have whatever I have explained in terms of features, pretty much all of them are part of this package, from explainability, ML monitoring, auditing, and user controls. Now this platform can be integrated with any of your ML ops platform. So okay, I think many people asked the question that why do I need an ML observability if I already have an ML ops? I think in one of the slides I told you, I have mentioned the scores, right? There is one for everyone. I mean, ML ops does everything, basic level, but it does everything. That's what ML ops is. Certain things it does much, much better. As compared to that, that's where ML observability frameworks are needed. You need an independent framework to do all of these things. Hence, we are able to integrate with any of your platforms through APIs and all. Yep, so we are launching this, and if you are starting your ML observability journey or AI governance journey, we believe that a good ML observability tool gives you a good AI governance framework, which makes AI scalable, acceptable, and deployable. Yeah, so that's it from our side. I'm open to questions, guys, if you have any.